Alright, so you are getting closer now to being able to write your first program. We are now going to start to learn about the structure that defines all programs. Now, it is true I could have you write a first program, like many programming courses do. But all this would be is me giving you some code and telling you to type it exactly as I give it to you and then run it. I want it to be the case that when you write and run your first program, you really understand it. So be patient, and you will be writing real programs very soon. Now, we talked about how a program is a sequence of instructions. Every program has an address in memory where it begins, and the CPU looks at that address in memory and executes the instruction found at that address, and then it goes to the next instruction, and so on until the end of the program. Now, the way this works is simple. The CPU keeps track of the address in memory of the programming instructions to execute. Every time an instruction is executed, the CPU modifies its internal address tracker to point to the address of the next instruction. So think of it like this. Let's suppose that you have a list of tasks to complete today. Now you number each of these items on a piece of paper like you see in front of you. Each of these steps can be thought of as a programming instruction. Now imagine that each of these numbers, 1 through 6, is the address of that particular instruction. So, for example, 3 is the address on the paper of the deposit paycheck instruction. So, you point a pen at item 1, you read it, and then you complete the task. After that task is complete, you mark it as being complete, and then you point your pen at the next instruction. You keep doing this until everything is completed. The pen acts as a pointer that points to the instruction being executed so that you can keep track of it. Now, at any given time during this process, you need to be aware of what step you are on. In other words, you have to keep track of the address on the paper where the next instruction is. Now, inside your computer, your CPU has something called an instruction pointer, which does exactly this. Think of it as being just like the pen in the example I just gave. At any time during a program, the instruction pointer contains the address in memory of the next instruction to execute. Once a programming instruction is executed, it does not get erased. It is still there in memory, exactly where it was before. This means that your CPU could execute that same instruction again. For example, if you already drove to the bank, but later on found out that you had to go back, it would be possible for you to move the pen back to the instruction that says, "Go to the bank." It is still written on the paper, and nothing stops you from executing that instruction again. Very often in a program, it is necessary to repeat an instruction. This is achieved by telling the CPU to go back in memory to the address of an instruction that has already been executed. For example, if you want to print the text "Hello Reddit" 10 times, you would not need to write "Hello Reddit" 10 times. You could write it once and then simply tell your program to go back to that instruction 10 different times. Now, it used to be the case that programmers had to keep track of the addresses in memory of various parts of the program that they might want to re-execute. Fortunately, modern programming languages remove all of that headache.